Welcome once again. Today we're going to be discussing a fantastic topic, which is relations, functions, and then mapping, right? So what's a relation? Now, a relation is just a connection between two sets. Now, when we talk about set, set is just a defined collection of objects, right? So it's a relation is any connection between these two sets, right? This set is actually referred to as is domain, then we have another set which can now be called the codomain. The codomain, right? So if you're discussing about relation, right? So this is any connection between these two sets is called a relation, right? Now, the arrow can be greater than or equal to between the factors of 6 and the factors of 16. So if you look at that very clearly, you can see that we have factor of 6, 1, 2, 3, and then 6, right? Then the factors for 16 is 1, 2, 4, 8, and 16, right? So if we're talking about relation right now, if we say that 1 is related to 1, right? We can actually say that all of them are related to each other, right? If you are picking out the factors. We also have 2 related to 2, but this is how we draw mapping from one place to the other. Now, this is just a relation. We have not described any other kind of maybe a mapping or a function. So a relation can just be a mapping between two sets since they are well defined, right? So we have types of relation. We have 4 types of relation, And the 4 types of relation are what? Number 1 is 1-to-1, 1-to-1. Now, what does 1-to-1 mean? 1-to-1 simply means every element in the domain has exactly one element in the codomain. So for instance, if I should do it on our diagram, 1-to-1 should look like, let's say 1, 2, 3, and 4, right? And this is mapped to 1, 2 is mapped to, let's say, 4, 3 is mapped to 9, then 4 is mapped to 16. Now, this kind of relation is called a 1-to-1 because each element in the codomain, remember, in the domain has exactly one element in the codomain. Sometimes we refer to this as images. Now, you can say that this is what? 1-to-1. Fantastic, right? Now, also we have another kind of relation which is many-to-one. What did I say? Many, like this, to 1. So this kind of relation, let's give a representation of it. Let's say you have -2, you have -1, you have 0, 1, 2, and so on and so forth. Now, if the image look like just 0, 1, and 4, where 0 is mapped to 0 over here, 0 is mapped to 0, right? And then 1 is mapped to 1. Similarly, 1 is mapped to 1, then 2 is mapped to 4, and also 2 is mapped to 4. Then you can say this is many from many image in the domain. You have 1, exactly 1 in the codomain or the range. We call it codomain or the range. Now, as we go further, you understand better. So this is a kind of many to 1, right? And we also have 1 to many. This kind of function can be your absolute value function, which we'll discuss later, right? So we also have many now to 1. So let's come to many. We have many mapped to what? To 1. Now, many mapped to 1, a perfect example will be this example over here. We have 3, and then we have like 5, and then 3 is mapped to 3, right? And the same 3 is mapped to 6, right? And then the same 3 is mapped to 9, right? While 5 is mapped to 10. Now, this kind of mapping, this kind of relation, right? This kind of relation is called many to 1. You understand? 1 to many, rather. This is what? 1 to many. We have done many to one over here. So, pardon, we have many to one, which we have done over here. So now we are discussing from one element to what? To many. One element in the domain giving rise to so many elements in the codomain. Then lastly, we now have many to many, right? We have many to many, right? Firstly, we start with one to one. We now went to many to one. Now we have one to many. And lastly, we have many to many. And this classic example is just where you have so many elements, like let's say 1, 2, 3, map to 4, 5, 6, right? This goes to this, 1 map to 5. Similarly, this goes to this goes to this goes to this map to this map to this. Then you can say that this is a classic example of many to many, right? Now, this is just definition of a relation. Now, when can we say a relation is a function, right? First of all, which means that a function or mapping by definition, right? Or mapping by definition, it is a relation. First of all, a function is a relation, which means it is a connection also between two sets, the domain and then the codomain, right? But now, when can you say this relation is a function? Now, a function is a relation in which image in the codomain, in which element of the domain has one and only one image in the codomain. Now, let me look for some example over here. Let me repeat myself, right? You say a function or a mapping is a relation in which element of the codomain has one and only one image in the codomain. One and only one image in the codomain. So what can we say about this? The codomain must be one. The codomain must be one. So which kind of relation can we say is a function? From observation, each element here should have one and only one image in the codomain. One and only one image in the codomain. So which kind of relation is a function? From observation, you can check from here. So we can clearly say that this is a function, right? Because we have only one image in the codomain. And also we have many to one, right? So let's pick some example over here. Let me look for some example. I have some example over here. So for instance, the relation y is equal to x squared minus 3x, right? Is a function that can be written in a number of different equivalent ways. You can write this in different ways, right? So you can write also that the function f of x is equal to x squared minus 3x. Yes, you can write it in this way. You can also write it in this way. Y is defined such that it is x mapping to x squared minus 3x, right? All these are definition of a function. You can also see it written as g of x or f of x, right? So this is a function in terms of g, and it is defined by x squared minus 3x. So clearly, just remember that a function or a mapping is a relation. So it's a relationship between two sets, the domain and the codomain. But each element here should have exactly one image here. Each element in the domain has one and only one image in the what? Codomain. So the only one we can classify as a function should be what? Many to one, right? Because we have one, and then one to one to one. These two classically are what? Are functions. Why? These other two are just relations, they cannot be functions, right? So this is a distinct definition of a function. And this is what you can be seeing us defining function in this way. Y is given as x squared minus 3x. F of x is given as x squared minus 3x. This is another definition of a function. Then you can see function defined in this term. Y is defined such that x is mapped to what? X squared minus 3x, which means the function here is given, like here, I can define this function as x squared, right? Because if you take this, the function that transforms this to this is just x squared. Can you see? When you square 2, you get 4. When you square 3, you get 9. When you square 4, you get 16. Now, similarly here, which kind of function is this? This is the absolute value function, right? I think this is an absolute value function. We call it absolute value function of x because when you take this is just a square also. This is a square, not absolute value function. This is just a square function. It is not absolute value because when you square -2, you get 4. But when you square -1, you also get 1. When you square 1, you get 1. When you square 2, you get 4. So what's the difference between this and this? It is now the definition of the domain, right? This domain started from just positive, while this goes from positive to negative. So this same function, they are all squared, but just the definition of the domain. So we have the domain is clearly where your values are taken from. Then the codomain is the image, right? The codomain, we have the image of each element here. The domain, codomain is also called the range, So this is a brief on functions. So you have to stay tuned to this channel. Then I'll be bringing more examples over here. All right, I'll be bringing more examples for us to discuss. And if you have any question, you can put on the comment section. If you have anything, right, you can put on the comment section so that I will get to answer them for you. Right? We actually have some other function here that we are going to be discussing. Some clear and well-defined functions. So see you in the next video. Thanks. Hope you get the idea of function and relation, the difference, and then the type of function that we have. So we're going to be discussing more functions as we go further. Thank you for watching, and share and like this video. Thanks.